Welcome to this lecture number 10 in this series on control systems 2. In the last session, in the last lecture, we actually studied the first companion form, how to derive the first companion form. That's basically how we can obtain a state space model in the first companion form from the transfer function of a system. Today, we'll be studying in a similar manner, we'll be looking at how to derive the second companion form of the state space model from the transfer function of a system. So again, assuming we have the same transfer function, nth order transfer function g of s given by beta naught Sn plus beta 1 Sn minus 1 plus beta 2 Sn minus 2 so on beta n, fine, divided by Sn plus alpha 1 Sn minus 1 plus alpha 2 Sn minus 2 plus so on up to alpha n. So we have an nth order, general nth order differential transfer function of a system that's given to us. We need to find the second companion form, that is the state space form of the system in the second companion form. So this is actually g of s, that means this is actually y of s divided by u of s. Simply cross multiplying, what we'll be getting is Sn plus alpha 1 Sn minus 1 plus alpha 2 Sn minus 2 so on up to alpha n. Cross multiplying this into y of s is equal to this into u of s, beta naught Sn plus beta 1 Sn minus 1 so on up to beta n into u of s. This was the first step. Now dividing throughout by s raised power n. Divide both sides by s raised power n. That gives us, when we divide this by s raised power n, this becomes 1 plus alpha 1 by s plus alpha 2 by s square plus alpha 3 by s cube plus so on alpha n divided by s raised power n. Y of s is equal to as the side say beta naught s raised power n divided by s raised power n becomes beta naught plus beta 1 by s plus beta 2 by s square plus so on beta n by s raised power n. This whole multiplied by u of s, which implies y of s plus alpha 1 by s y of s plus alpha 2 by s square y of s, simply multiplying so on up to alpha n s raised power n of y of s is equal to beta naught u of s plus beta 1 by s u of s so on beta n divided by s raised power n u of s. Fine. Simply multiplying, तो यहाँ से हम खाली y of s रखेंगे on the left hand side. All the other terms on the left hand side will be shifted to right hand. So what we'll be getting is y of s is equal to minus alpha 1 by s ys minus alpha 2 by s square y of s minus alpha 3 by s cube y of s so on minus alpha n by s raised power n y of s plus beta naught u of s plus beta 1 by s u of s, so on up to beta n by s raised to power n u of s. y of s is equal to 1 by s, ठीक है. 1 बाय एस कहाँ कहाँ पे, एक तो ये टर्म है, दूसरी आपकी ये टर्म. सो 1 बाय एस इन दोनों में से कॉमन निकाल के यू विल गेट बीटा 1 यू ऑफ एस माइनस अल्फा 1 वाई ऑफ एस, ठीक है. ऐसे ही प्लस 1 बाय एस स्क्वायर, 1 बाय एस स्क्वायर यहाँ पे, और इसके बाद जो टर्म है बीटा 2 बाय एस स्क्वायर यू ऑफ एस. सो दिस विल बी बीटा 2 यू ऑफ एस माइनस अल्फा 2 वाई ऑफ एस. ऐसे ही एस 1 बाय एस क्यूब कॉमन निकाल के, 1 बाय एस 4 कॉमन निकाल के अप टू 1 बाय एस रेज पावर एन, फाइंडिंग 1 बाय एस रेज पावर एन बीटा एन यू ऑफ एस प्लस अल्फा एन वाई ऑफ एस, ठीक है. तो हमने ये सारी टर्म्स कॉमन निकाली. और ये जो हमारे पास इक्वेशन है एंड वन other term is left in here, that is this term beta naught u of s. 1 by s, 1 by square, 1 by s cube, 1 by s raised power n common, and these will be the terms, factors that will be getting inside, plus beta naught u of s. So this is our equation that will be modeling using the block diagrams. Fine. So we'll obtain the block diagram model of this equation. So we have y of s equal to 1 by s times all those terms. So that means हमारा जो output है यहाँ पे, that is y of s, and it is summation of a number of terms इनमें से जो एक टर्म है that is beta naught u of s. So if our input is u of s, this gets multiplied with beta naught and we obtain beta naught u of s. Fine. बीटा नॉट यू ऑफ एस तो हो गया. अब आपकी फिर बाकी टर्म्स है, दैट्स पहली जो टर्म थी दैट वाज 1 बाय एस बीटा 1 u of s माइनस अल्फा 1 y of s. 1 by s beta 1 u of s minus alpha 1 y of s. So we have an integrator here 1 by s. इसका जो इनपुट होगा that will be beta 1 us minus alpha 1 ys. तो यहाँ से बीटा 1 us आ गया माइनस अल्फा 1 ys minus this is alpha 1 and ys is actually our output of the system. तो यहाँ से बीटा 1 us आ रहा है ऊपर से, यहाँ से माइनस अल्फा 1 ys is passing through 1 by s, that means this becomes 1 by s times बीटा 1 us minus अल्फा 1 ys. उसके बाद जो हमारी टर्म है that is 1 by s square times बीटा 2 us minus अल्फा 2 ys. Now let me show what I am doing here. यहाँ पे हम एक इंटीग्रेटर लेंगे 1 by s तो यहाँ से ऊपर से बीटा 2 u of s आ रहा है, नीचे से माइनस अल्फा 2 y of s is passing through one integrator. That means at this point I have the term 1 by s beta 2 us minus alpha 2 ys, and then it's passing through this summer and passing through another integrator. That means at this point this signal will become 1 by s square times beta 2 us minus alpha 2 y of s. So this term is made to pass through two integrators, and in this manner, such that we obtain 1 by s square beta 2 us minus alpha 2 y of s. ऐसे ही बाकी टर्म्स भी आ जाएंगी इस सिस्टम में, एंड फाइनली विल बी हैविंग आफ्टर a chain of n integrators, this will be nth integrator. So if this is nth integrator, it will pass through n integrators. That means यहाँ से जो term आ रही है बीटा n us, यहाँ से आपका minus alpha n y of s, it will pass through n integrators. That means at the output of this will be getting 1 by s raised power n beta n u of s. So each and every term will be passed through the number of times they need, through the number of integrators they need to be multiplied with actually, so as to obtain the output response. So जैसे फिर हमने लास्ट टाइम किया था, now we can assign variables. लास्ट टाइम हमने यहाँ से x1 स्टार्ट किया था, यहाँ पे x2 स्टार्ट, then x3 x4. Instead of doing that, we can assign variables in any direction. These are simply variables. Let us say this is x1, fine, this is x2. After this is x1, उसके बाद जो दूसरा इंटीग्रेटर होगा यहाँ पे बीच में, उसके बाद x2 होगा, उसके बाद x3 होगा, यहाँ पे ये xn-1 आएगा. फाइनली दिस विल बी xn आफ्टर द nth इंटीग्रेटर. So we are assigning variables now. So starting from the leftmost, in the first companions form, we started with the rightmost, assigning variables x1, x2, x3 up to x raised power n. In this case, from the leftmost integrator, we have a chain of n integrators again. In this case, these integrators are separated by a summer. In the last case, in the first companion form, these integrators were not separated by a summer. So in this case, we'll be starting assigning the variables from the leftmost integrator, the output of the leftmost integrator. So this is x1, this is x2, this is x3, so on. This will be xn-1, and from the nth integrator we'll be getting the output xn. That means if the output is x1, the input of this integrator will be x1 dot, input of this integrator will be x2 dot, input of this integrator will be x3 dot, input of this integrator will be xn-1 dot, and input of this integrator will be xn dot. From the first companion form, this is different. We are assigning the variables in such a fashion. This is different from the first companion form in two ways. One, we are assigning variables from the left hand side instead of the right hand side, fine. And two, these integrators are separated here by summers. So accordingly we have to find out the output. Now आपके पास x1 dot, x2 dot, x3 dot, x4 dot, ये सारी terms हैं. Now from the block diagram, so if this is x1 dot, यहाँ पे x2 dot होगा, यहाँ पे xn-1 dot है, and this is xn dot. From the block diagram we can see what is the value of xn dot. Xn dot is beta 1 u minus alpha 1 y plus xn minus 1. Xn dot is equal to summation of three terms. One is beta 1 u, beta 1 u प्लस यहाँ से जो टर्म आ रही है दैट्स xn-1 प्लस beta 1 u प्लस alpha 1 times y. Fine. So we need to actually first define what is this output y here. So y is what? From the block diagram, y is summation of beta naught u plus xn simply. So y is xn plus beta naught u. ठीक है, तो ये हमारी इक्वेशन हो गई, द आउटपुट इक्वेशन. सो सबस्टिट्यूटिंग दिस, यहाँ पे सबस्टिट्यूट जब इसको करेंगे, एक्स एन डॉट विल बी इक्वल टू एक्स एन माइनस वन प्लस बीटा वन यू प्लस अल्फा वन एक्स एन प्लस बीटा नॉट यू. Fine. That means this is xn minus 1 plus this is minus alpha 1 y plus beta 1 u minus alpha 1 xn minus alpha 1 beta naught u. So u और u कॉमन निकाल के what we are getting here is xn minus 1 minus alpha 1 xn plus beta 1 minus alpha 1 beta naught u. So this is xn dot. ऐसे ही हम एक्स एन माइनस वन डॉट निकाल सकते हैं. ठीक है, या फिर लेट्स फर्स्ट ऑफ ऑल फाइंड आउट एक्स वन डॉट. लेट्स स्टार्ट फ्रॉम द लेफ्ट हैंड साइड. एक्स वन डॉट क्या है? एक्स वन डॉट इज बीटा एन यू प्लस एल माइनस अल्फा एन वाई. बीटा n u minus alpha n y. Substituting the value of y here, beta n u minus alpha n y is beta naught u plus x n. So beta n u minus alpha n beta naught u minus alpha n x n. Fine. That means minus alpha n xn plus beta n minus alpha n beta naught of u. So ये आपका x1 डॉट हो गया. This is x1 डॉट. Let's calculate x2 डॉट. x2 डॉट क्या होगा? Looking at this general form now, x2 dot will be beta n u minus alpha n minus 1 times y x2 डॉट यहाँ पे हो गया. यहाँ पे पहले एक समर है, उसके बाद एक इंटीग्रेटर है, ये आपका x इससे पहले x2 डॉट है. ठीक है, तो यहाँ से आपकी सिग्नल जो आ रही है दैट इज बीटा n माइनस वन, और यहाँ से आपका माइनस अल्फा n माइनस वन है. ठीक है, आपका जो x2 डॉट है it is beta n minus 1 times u minus alpha n minus 1 times y plus x1. ठीक है, when you will substitute the value of y here, you will find out and take out the common terms from here. x2 dot will be equal to x1 minus alpha n minus 1 xn plus beta n minus 1 minus alpha n minus 1 beta naught of u. ऐसे x3 डॉट क्या होगा? Looking at x2 dot, it should be beta n minus 2 times u minus alpha n minus 2 times y plus x2. ठीक है, when you will substitute the value of y here, you will get x2 minus alpha n minus 2 times xn plus बीटा n माइनस टू माइनस अल्फा n माइनस टू बीटा नॉट इंटू यू। ठीक है, ऐसे ही अप टू एक्स एन डॉट, एक्स एन डॉट हमने ऑलरेडी निकाला हुआ है, दैट्स एक्स एन माइनस वन माइनस अल्फा वन एक्स एन प्लस बीटा वन माइनस अल्फा वन बीटा नॉट यू। So now let's put these in. This is equation number 2. This is equation number 3. This is your equation number 4. This is equation number 5. Let's put them in the state space form. The matrix form x1 dot, x2 dot, x3 dot, so on up to xn dot. This is something times x1, x2, x3, so on up to xn plus something times u। ठीक है, तो x1 डॉट सबसे पहले x1 डॉट इज माइनस अल्फा एन एक्स एन, दैट मीन्स x1, x2, x3, x4 उनका सबका कोफिशिएंट 0 है, प्लस दिस थिंग टाइम्स u। So this will be 0x1, 0x2, 0x3, so on up to minus alpha n times xn। ठीक है, लास्ट टर्म इसका माइनस अल्फा एन एक्स एन होगा प्लस बीटा एन माइनस अल्फा एन बीटा नॉट, बीटा एन माइनस अल्फा एन बीटा नॉट। ठीक है, तो ये आपका x1 डॉट हो गया। नाउ x2 डॉट क्या है आपका? x2 डॉट इज x1 माइनस अल्फा n माइनस वन x2 dot is x1 minus alpha n minus 1 xn. So this is 1 times x1, 0 times x2, 0 times x3 up to minus alpha n minus 1 times xn. Fine. Here plus beta n minus 1 alpha n minus 1 beta naught, beta n minus 1 minus alpha n minus 1 beta naught। ठीक है, ऐसे अब आपका x3 डॉट है, if you look at x3 dot it is x2 minus alpha n minus 2 xn, so that means 0 times x1, 1 times x2, 0 times x3 minus alpha n minus 2 times xn plus beta n minus 2 alpha n minus 2 beta naught, beta n minus 2 minus alpha n minus 2 beta naught। So you can see a pattern emerging। Next क्या होगा यहाँ पे 0 0 1 होगा, so on up to minus alpha n minus 3 times x4 और यहाँ पे आपका बीटा n माइनस 3 माइनस अल्फा n माइनस 3 बीटा नॉट। So on xn डॉट क्या है? xn डॉट इज xn माइनस 1 माइनस अल्फा 1 xn, that means this will be 0 times x1, 0 times x2, 0 times x3 so on up to 1। जैसे पहले एक एलिमेंट होगा that will be 1 xn माइनस 1 माइनस अल्फा 1 टाइम्स xn। ठीक है, प्लस यहाँ से जो this will be beta 1 minus beta naught alpha 1 beta naught। तो अगर इससे पहले वाली हम टर्म देखेंगे उसमें 0 0 0 सो ऑन अप टू 1 0 माइनस अल्फा 2 होगा यहाँ पे, और यहाँ पे बीटा 2 माइनस अल्फा 2 बीटा नॉट होगा। So that will be the second last term. And I say y we have already calculated. Y is equal to equation number 1, xn plus beta naught u. Y is equal to xn plus beta naught u. x1 so on up to xn plus something times u. X y is equal to x y is equal to beta naught u plus xn. That means 0x1 0x2 1 times xn plus beta naught times u. So this is your second companion form. Now if we compare this with the first companion form that we derived yesterday, day before, the first companion form is 0 1 0. See these terms. What is C matrix here? Okay, what is B matrix here, what is D matrix here, and what is the A matrix here. If we compare the A matrices, B matrices, C matrices of the first companion form with the second companion form, these are simply A matrix of first companion form is equal to A matrix of second companion form transpose of it. B matrix of first companion form is C matrix of second companion form transpose of it. C matrix of first companion form is B matrix of second companion form, the transpose of it, while as D matrix of first companion form is D matrix of second companion form. So if you have already derived the first companion form, you can simply derive the second companion form of by only finding out the transpose of these matrices. Okay? A matrices will be the transpose, B matrices will be the C matrix transpose, C will be the B matrix transpose. तो जैसे हमने लास्ट टाइम दो न्यूमेरिकल्स किए थे, we had to obtain the first companion form of this system. We have to obtain the first companion form of this system. Now let's say we want to obtain the second companion form of this same system. What will be the second companion form be? x1 dot, x2 dot, x3 dot is equal to something times x1, x2, x3 plus something times u. Y is equal to something times x1, x2, x3 plus something times u. Okay, so this is the first companion form that we had derived. We want to derive its second companion form. So what will the second companion form be? The A matrix of second companion form will be the A matrix of first companion form, but the transpose of it. So अगर यहाँ पे 0 1 0 है, 0 0 1 है, so the second companion form will be 0 1 0 0 0 1. The transpose of this particular matrix is 0 1 0 0 0 1 minus 1 minus 5 minus 4 minus 1 minus 5 minus 4. And B matrix of second companion form will be the C matrix, the transpose of it. यहाँ पे 0 minus 4 minus 3 था, यहाँ पे 0 minus 4 minus 3 आएगा, वहाँ पे एक रो मैट्रिक्स था, यहाँ पे अब एक कॉलम मैट्रिक्स बन जाएगा. and C matrix of second companion form will be the B matrix of first companion form but the transpose of it. So अगर ये वहाँ पे column matrix था यहाँ पे एक row matrix बन जाएगा 0 0 1 and similarly B naught of the D matrix of first companion form and the D matrix of second companion form, they are simply equal. So this will be the second companion form of this system. So we had obtained the first companion form. We can directly now obtain the second companion form by finding out that by following this particular rule. Simply following this particular rule where A matrix of second companion form, you can write this as A matrix of first companion form is equal to A matrix, or you can say A matrix of second companion form is A matrix of first companion form transpose. B matrix of second companion form is C matrix of first companion form transpose. C matrix of second companion form is B matrix of first companion form transpose, and this equation holds as it is. So A matrix of, if you have the second companion form given to you, you can find out the first companion form, or if you have the first companion form given to you, you can find out the second companion form. So this is all about the second companion form. Now we are left with the Jordan canonical form. We'll do that in the next lecture. If you have any questions.